Good afternoon, friends, and welcome back again to Parijat Sir classes. Once more, I welcome you to another session of Parijat Sir classes. So, today we have another special class for Mathematics class 12. Basically, आज class 12 के Mathematics के इस topic से हम deal करेंगे, which is the relations. We will be doing the relations of Mathematics class 12. Okay. So, I'm already uploading mathematics each and every chapter. So please go through my classes, which is Parijat Sir classes. Follow करते रहिए Parijat Sir classes. And one important thing is that please go through the full lecture of this session. अगर आप इस पूरे सेशंस के लेक्चर को पूरा देखेंगे from top to bottom, then only you will be able to understand. And I have covered the full syllabus here. Relations का full syllabus जो है board के लिए, that is fully covered. So please go through the whole session of this so that you can cover up पूरा relations मैं यहाँ पे cover up करूँगा, and it is for both ISC and CBSE class 12. So ISC and CBSE class 12 students, please follow this so that you can cover up the whole relations. And one request is that please like, share and subscribe जरूर कर दीजिए मेरे चैनल को. Like, share and subscribe please मेरे चैनल को जरूर कर दीजिए so that I get motivated to make more and more videos for you. तो चलिए without wasting any more, let us move on to the topic relations of class 12. तो फर्स्ट ऑफ ऑल देखिए, इन रिलेशंस वी विल बी लर्निंग सर्टेन टाइप ऑफ रिलेशंस, दैट इज वन इज रिफ्लेक्सिव, वन इज सिमेट्रिक एंड वन इज ट्रांजिटिव. ये तीन रिलेशंस हम लोग सीखेंगे. लेट अस फर्स्ट कम टू द रिफ्लेक्सिव रिलेशन. देखिए मैं यहाँ पे आई विल मेक यू अंडरस्टैंड ईच एंड एवरी स्टेटमेंट ऑफ दिस सो दैट आपको सॉल्व करने में थोड़ा सा इजी हो. सो प्लीज फॉलो माई लेक्चर वेरी केयरफुली and listen to the things what I am discussing. First, we will discuss the reflexive relation. A relation R on a set A. आपको एक set A दिया जाएगा, from where you have to choose your elements. इस set A से you have to choose your elements and a relation will be given choosing the elements from set A. set A से elements choose करेंगे और एक relation दिया रहेगा. So reflexive के लिए क्या होगा देखिए, when you choose element from set A, it is to be related to itself. ये बहुत important word है, itself means reflexive relation में जो relation होगा, in that case you have to choose the same element and apply the condition which is given to you. Same element we have to choose and apply the condition which is given to you. Okay? और वो condition अगर same element choose करने से match करता है, then it is reflexive. For example देखिए, this is set A which is containing the elements 1, 2, 3. Okay? We have to choose a relation in this R. See what elements are chosen: 1, 1, 2, 2, 3, 3, 1, 3 and 2, 1. Reflexive के लिए मैंने क्या कहा आपको, you have to choose the same elements. So see 1, 1 is there. If I take 1 तो 1, 1 मेरे पास है. If I take 2 तो 2, 2 मेरे पास है. If I take 3 then 3, 3 मेरे पास है. So when I have chosen every element, I have to choose every element of A, and if I choose every element of A, तो उनको कैसे रिलेशन में रहना चाहिए? सेम 1, 1, 2, 2, 3, 3. ये तो है. उसके साथ अगर और कुछ है, that doesn't make a sense, क्योंकि मेरे पास सेट A के जो एलिमेंट्स थे 1, 2, 3, उनको मैंने सेम कॉम्बिनेशंस में रखा है, विच इज द रिफ्लेक्सिव कंडीशन. सेम कॉम्बिनेशन में रखा है. विच इज द रिफ्लेक्सिव का कंडीशन होना चाहिए, राइट। सिंस ये तीनों आपके पास है तो इट इज अ रिफ्लेक्सिव रिलेशन इन ऑन ए, तो रिफ्लेक्सिव रिलेशन हो गया, राइट। नाउ सी अनदर थिंग, R1 1 हमारे पास है, 3 हमारे पास है, बट वी डोंट हैव 2 वी डोंट हैव 2 सो इससे क्या होगा, 2 बिलोंग्स टू ए। देखिए एलिमेंट 2 जो है वो सेट ए में है, तो 2 भी होना चाहिए, बट 2 इज नॉट देयर, सो इट इज नॉट अ रिफ्लेक्सिव, इट इज नॉट अ रिफ्लेक्सिव रिलेशन ऑन ए। 2 मिसिंग है, यहाँ पे 1 था, 2 था, 3 था, सो इट इज अ रिफ्लेक्सिव, बट हियर 1 इज देयर, 3 इज देयर, 2 नहीं है। ऑल्दो 2 इज अ एलिमेंट ऑफ सेट ए, 2 नहीं है, so it is not reflexive. Similarly, see, we will choose from the natural number set. क्या choose करेंगे? We will choose 2 coordinates, right? And we are seeing x greater than equal to y is a reflexive relation on natural number. ये condition x greater than equal to y, क्या ये reflexive है? I told you रिफ्लेक्सिव के लिए हमको क्या करना होता है, we will choose the 2 same elements from R। तो क्या मैं बोल सकता हूं x greater than equal to x, क्या ये कंडीशन काम आएगा इस सम्स के लिए, इस वाले के लिए क्या ये रिलेशन काम आएगा? कैन आई टेल x इज ग्रेटर देन और इक्वल टू x? 100% बोल सकते हैं, बिकॉज एवरी नेचुरल नंबर इज ग्रेटर देन और इक्वल टू इटसेल्फ, सो आई कैन टेल दिस कंडीशन इज वैलिड फॉर दिस। सो ये रिफ्लेक्सिव, ये जो कंडीशन है, ये जो कंडीशन है, दिस कंडीशन, ये जो कंडीशन है ऑन अ नेचुरल सेट, सो दिस इज अ रिफ्लेक्सिव रिलेशंस कंडीशन। ये कंडीशन रिफ्लेक्सिव रिलेशन को वैलिड करता है, राइट। अनदर सम, सेट ऑफ पैरेलल लाइंस। तो क्या मैं बोल सकता हूं इफ आई चूज 2 लाइंस, इफ आई चूज 2 लाइंस, कैन आई टेल L1 इज पैरेलल टू L1? बिकॉज रिफ्लेक्सिव में हमको सेम लेना पड़ेगा, रिफ्लेक्सिव में हमको सेम लेना पड़ेगा। दिस इज द रिफ्लेक्सिव कंडीशन x R x, मतलब टेक द सेम एलिमेंट्स और बीच में कंडीशन लगा दीजिए। तो टेक द सेम एलिमेंट्स L1 एंड L1, बीच में कंडीशन लगा दिया, पैरेलल इज पैरेलल टू, सो आई कैन इजिली टेल दैट लाइन 1 इज पैरेलल टू इटसेल्फ, एवरी लाइन इज पैरेलल टू इटसेल्फ, ठीक है। सो इज पैरेलल टू, ये एक रिफ्लेक्सिव रिलेशन है, ये एक रिफ्लेक्सिव रिलेशन है। नेक्स्ट कम टू सिमेट्रिक रिलेशन। देखिए सिमेट्रिक रिलेशन में क्या करना पड़ेगा, वी हैव टू चूज 1 कोऑर्डिनेट a, b फ्रॉम द सेट a, b, एक कोऑर्डिनेट चूज करेंगे, राइट। सो वॉच हियर, सिमेट्रिक में क्या करना पड़ेगा, राइट द 2 नंबर्स ऑन 2 साइड्स एंड अप्लाई द कंडीशन, जो भी कंडीशन होगा। Now interchange the number and apply the same condition. If it is still following, if it is still obeying, means it is a symmetric relation. You will choose 2 elements from the set A, ठीक है। अब क्या करेंगे, write the 2 elements with the condition R in the middle. Now interchange the numbers with the condition R in the middle. अगर ये दोनों सेम आ रहा है then it is a symmetric relation. Okay. For example, I have taken a condition perpendicular to. तो देखिए मैं क्या लिख रहा हूं, I have taken 2 lines, L1 is perpendicular to L2, L1 is perpendicular to, ये मैंने कंडीशन लगाया R, ये मैंने 2 एलिमेंट चूज किए A, दिस इज द कंडीशन, इज परपेंडिकुलर टू, दिस इज B। अब मैंने कहा इसको रिवर्स में लिखिए, B ये मेरा रिलेशन है, इज परपेंडिकुलर टू, ये मेरा फर्स्ट वैल्यू है, if L1 is perpendicular to L2, is L2 perpendicular to A? yes, ये कंडीशन 100% वैलिड है. सो is perpendicular to is डेफिनेटली, ये जो परपेंडिकुलर कंडीशन है, is perpendicular to this condition is a symmetric relation. ये एक symmetric relation है. Now watch, they have given that you have to choose number from this set 1 2 3 4. दो relations हैं R1 and R2. I will take R1 as these conditions. R1 ये ले लिया मैंने, R2 मैंने ये ले लिया. Now is R1 a symmetric? देखिए, अगर 1 3 है तो 3 1 होना चाहिए, हाँ है. अगर 1 4 है तो 4 1 होना चाहिए, हाँ है. अगर 2 2 है तो फिर रिवर्स करेंगे, 2 2 ही है. तो इसमें सारे वैलिड है. तो R1 इज अ सिमेट्रिक रिलेशन. नाउ कम टू R2. अगर 1 1 है तो इंटरचेंज से भी 1 1 ही होगा, 2 2 से 2 2 होगा, 3 3 से 3 3 होगा, 1 3. तो क्या मेरे पास 3 1 है? क्या मेरे पास 3 1 है? 3 1 तो इस सेट में नहीं है. सो दैट मीन्स 3 1 अगर आपके पास नहीं है in the set R2, that means ये symmetric relation. R2 is not symmetric. R2 is not symmetric, right? We will be dealing it with more details. तो पहले ये थोड़ा सा इंट्रोडक्शन मैं दे रहा हूं. नेक्स्ट कम टू द ट्रांजिटिव रिलेशन. देखिए, ट्रांजिटिव रिलेशन क्या है? वी विल टेक हियर, फर्स्ट टेक एनी टू एलिमेंट्स और बीच में कंडीशन अप्लाई कर दीजिए. नाउ टेक द सेकेंड एलिमेंट एंड अनदर थर्ड एलिमेंट, बीच में कंडीशन अप्लाई कर दीजिए. एंड नाउ टेक द फर्स्ट एलिमेंट एंड द लास्ट थर्ड एलिमेंट एंड बीच में कंडीशन अप्लाई कर दीजिए. इफ दिस इज वैलिड एंड दिस इज वैलिड, तो क्या ये भी वैलिड है? इज दिस वैलिड? इज दिस वैलिड? अगर ये वैलिड है, अगर ये वैलिड है, then I can say that it is a transitive relation. Then I can say it is a transitive relation, right? See, we will see with the help of more and more sums. So let us see first. Show that the relation are on the set n. तो हमको कहां से चूज करना पड़ेगा? From natural number set. Here we will take the coordinates from the set R. और ये वैल्यूज जो हैं x एंड y, ये वैल्यूज जो हैं x एंड y, we will be taking it from the natural set. Okay, they are telling that the relation R on the set of all natural numbers is defined by this. x कंडीशन क्या है? देखिए, x divides y, ये रहा मेरा कंडीशन. X divides y. तो first let us see, they are telling is it a transitive relation? तो transitive के लिए क्या होगा? We will choose x, y and z from the natural number. And now let us first apply x condition क्या है? Divides y. x divides y. ठीक है. उसके बाद मैंने क्या कहा था? अब आपको क्या लेना पड़ेगा? अच्छा, दिस इज f if and y divides z. तो is x divides z. तो ये हमको चेक करना पड़ेगा, ये चेक करना पड़ेगा. ओके, सो फर्स्ट दे आर टेलिंग x divides y. x divides y. That means y is some multiple of x. y is some multiple of x. उसके बाद क्या बोल रहे हैं? उसके बाद बोल रहे हैं y divides Z. So Z should be some multiple of Y. Okay, so I can write this A into KX. Now I have to check is can X divide Z. Can X divide Z? तो देखिए Z में क्या आ गया, A K X. So definitely Z is a multiple of X. Z is some multiple of X. Therefore I can tell that X will divide Z. ये valid है, right? A is actually A and K, they are any integers. Okay, so X will divide Z. X will definitely divide Z. और अगर X divide Z है तो हम क्या लिखेंगे यहाँ पे, X R Y and Y R Z. So therefore X R Z, ये तीन कंडीशंस जो है ये वाला वैलिड हो गया है. सो इट इज अ ट्रांजिटिव रिलेशन. इट इज अ ट्रांजिटिव रिलेशन, राइट? इट इज अ ट्रांजिटिव रिलेशन. ये हो गया वैलिड. नेक्स्ट, दे आर टेलिंग चूज नंबर्स फ्रॉम नेचुरल नंबर्स. ओके, यहां पे क्या है, इज लेस देन. देखिए कंडीशन क्या दिया है, इज लेस देन वाई. इज लेस देन वाई, क्या ये ट्रांजिटिव है? सो लेट्स चेक. फर्स्ट ऑफ ऑल वी हैव टू चूज एक्स, वाई एंड जेड फ्रॉम द नेचुरल सेट, राइट? तो हियर आई कैन टेल दैट इफ एक्स, कंडीशन क्या है, इज लेस देन y. If x is less than y and y बीच में कंडीशन दीजिए is less than z. x is less than y is less than z. तो क्या is x less than z? क्या ये कंडीशन वैलिड है? 100% देखिए वैलिड है. इफ अगर मैं कहूं इफ 1 is less than 2 and 2 is less than 3, therefore मैं बोल सकता हूं 1 is less than 3, करेक्ट? ये तो बोल सकता हूं. सो दैट मीन्स यस दिस कंडीशन इज वैलिड. दैट मीन्स ये वाला जो कंडीशन ट्रांजिटिव का होता है, इफ x रिलेटेड टू y एंड y रिलेटेड टू z, देयरफॉर x इज रिलेटेड टू z, ये वाला वैलिड हो रहा है. सो दैट मीन्स इट इज अ ट्रांजिटिव रिलेशन. It is a transitive relation, right? It is a transitive relation. Clear? Let's see more. If L be the set of all straight lines, क्या लेना है? Straight lines. Relation, ये देखिए कंडीशन है, is parallel to. Is it a transitive relation? So let's see. If L1 is parallel to L2 and L2 is parallel to L3, is L1 parallel to L3? ये क्या है? So let's see. This is a line L1. It is parallel to L2. and L2 is parallel to L3. So isn't L1 parallel to L3? Yes, L1 is parallel to L3. मतलब is parallel to is a transitive relation. Is parallel to is a transitive relation, right? Now, let's see. There are three sets given, and we have to choose the numbers from ABC. इसमें से लेना है. The elements are ABC and see how they are made. So they are telling find whether each of R1, R2 and R3 is reflexive, symmetric and transitive. So let's check. R1, देखिए रिफ्लेक्सिव के लिए क्या चूज करेंगे? A same number on both sides. तो A B C that means you should have A हाँ है, B B हाँ है, C C हाँ है. That means this is reflexive, this is reflexive. R1 is reflexive. तो R1 क्या है? R1 is reflexive. नेक्स्ट सिमेट्रिक का टेस्ट करते हैं. इफ ए बी इज देयर तो क्या बी ए है? तो देखिए बी ए तो है नहीं. ए बी इज देयर तो बी ए नहीं है, राइट? ए सी इज देयर तो सी ए है. ए सी इज देयर सी ए है, बट ए बी इज देयर सो बी ए नहीं है. बी कॉमा ए डज नॉट बिलोंग टू R1. तो ये सिमेट्रिक नहीं है. लेट्स सी द ट्रांजिटिव. इफ ए बी इज देयर, ये रहा ए बी. बी सी इज देयर, ये बी सी. तो क्या ए सी है? ए सी, ए सी भी है ना. ए बी इज देयर, देखिए ए बी इज देयर. So please watch. If AB is there, BC is there, तो क्या AC है? हाँ AC भी है. Yes, that means it is transitive. तो transitive ये हो जाएगा. Next come to R2. चलिए R2 में आते हैं. इज ए देयर? ए नहीं है, बी बी नहीं है, सी सी नहीं है. सो इट इज नॉट रिफ्लेक्सिव. इफ ए बी इज देयर, क्या बी ए है? यस. इफ ए सी इज देयर, क्या सी ए है? यस. दैट मीन्स इट इज सिमेट्रिक. नेक्स्ट कम टू ट्रांजिटिव. इफ ए बी इज देयर, बी सी इज देयर, तो बी सी तो है नहीं, बी सी भी नहीं है, राइट? BC is also not there. That means it is not a transitive relation. Next come to R3. Is AA there? AA नहीं है, BB नहीं है, CC नहीं है, so it is not reflexive. If AB is there तो क्या BA है? नहीं, BA भी नहीं है, so it is not symmetric. If AB is there, BC is there, तो क्या AC है? AC नहीं है, CA है, तो it is neither transitive also. It is neither transitive also, right? So this is how we solve the three relations R1, R2 and R3, right? Next, see, the set is given 1, 2, 3, and here are the coordinates taken. They are telling show that it is reflexive but not transitive. तो चलिए let's see. For reflexive I know that I should have the same. तो 1 है तो 1 1 होना चाहिए, करेक्ट. 2 है तो 2 2 होना चाहिए, करेक्ट. 3 है तो 3 3 होना चाहिए, करेक्ट. So it is a reflexive relation. It is a reflexive. Now transitive. Transitive में अगर 1 2 है, 2 3 है, तो 1 3 होना चाहिए. लेट्स सी. 1 2 है, 2 3 है, लेकिन 1 3 तो इसमें है नहीं, so it is not transitive, it is not a transitive, right? Next, see here, we have to choose the elements 1 2 3, इनका टेस्ट होना चाहिए. They are telling is symmetric, इसमें इसको यूज करके हमको दिखाना होगा is symmetric but not reflexive. देखिए रिफ्लेक्सिव के लिए क्या होना चाहिए, you should have reflexive के लिए you should have 1 1 2 2 and 3 3. ये तीनों ही नहीं है इसमें, that means it is not reflexive, it is not reflexive. Next come to symmetric. अगर आपके पास 1 2 है तो 2 1 होना चाहिए. Is it there? Yes. तो ये symmetric है, it is symmetric. Like अगर यहाँ पे ऐसा होता कि आपका 1 2 है तो 2 1 होना चाहिए, 2 1 भी है. अगर 1 3 है तो 3 1 होना चाहिए. अगर 2 3 है तो 3 2 भी होना चाहिए, right? But here they have given only 1 2, तो 2 1 भी है, that means it is symmetric, correct? Let's see the next one. Check the following relations R and S for reflexivity, symmetry and transitivity. तो तीनों चीज को R and S को चेक करना है, right? See, for the R part, the condition is given is divisible by को टेस्ट करना है, is divisible by को टेस्ट करना है, right? So let's first see about R. This is for the R part we are testing. Okay, first is reflexivity चेक करते हैं. चलो, reflexivity. So for reflexivity we know that we have to choose the same elements A, R, A. Okay, so now we will apply A is divisible by A. Is it possible? Yes, it's possible. तो ये reflexivity condition करेगा. Next, let us check the symmetric condition for R. Okay, symmetric में क्या होगा? A is divisible by B. If A is divisible by B and B is divisible by C, is A is divisible by C, ये चेक करना है. तो let's see, A divisible by B, that means A is divisible, A R B means B is divisible by A. So B should be something A. B should be something A. Okay, they are telling C is divisible by B. C is divisible. इसको थोड़ा सा let me, because the language is this. Please, 1 minute. Okay, so it should be written like this because ARB, देखिए ARB means B divisible by A. So if B is divisible, ARB, B divisible by A. So 1 minute, ये वाला नहीं आएगा. Let me test it now. Okay. If B is divisible by A, for this condition A or B, okay, B divisible by A, that means I can write B equal to KA, okay, is इसका मतलब है A divisible by B, is A divisible by B, right? So if B is divisible by A, so is A divisible by B? A divisible by B, तो what is A divisible by B? So देखिए A divisible by B means I can write A by KA, तो ये तो divisible नहीं हो रहा है, ये तो divisible नहीं हो रहा है, that means it is not symmetric. It is not symmetric, right? Next, come to the transitive part. Transitive part. Okay. If first we will try this A or B. इसका मतलब क्या है? B is divisible by A, therefore B equal to AK, right? And B C, इसका मतलब क्या है? C is divisible by B, therefore हम क्या लिख सकते हैं? C is equal to suppose MB, तो C equal to क्या हो गया? M AK, right? तो हम now we will test is A, इसका मतलब क्या है? is C is divisible by A, is C divisible by A? So let's see. C is MAK, तो MAK by A, so friends, as you can see now here that it is coming how much? It is coming MK. That means C is easily divisible by A. That means these all conditions are valid. That means ये transitive है. This is a transitive relation, right? Next, come to the second part, which is about S. So for S, let us check the reflexivity. What is S? L1, S, L2. If L1 is perpendicular, देखिए कंडीशन क्या दिया है? Perpendicular. Okay. So first let's check the reflexivity of S. Reflexivity of F. Reflexivity of S. L1 is perpendicular to L1. क्या ये पॉसिबल हो सकता है? इन रिफ्लेक्सिविटी वी टेक द सेम थिंग ऑन बोथ साइड्स. बीच में कंडीशन देते हैं और दोनों तरफ सेम लेते हैं. सो इज अ लाइन परपेंडिकुलर टू इटसेल्फ? नो, इट इज नॉट पॉसिबल. तो ये रिफ्लेक्सिविटी नहीं होगा. नेक्स्ट, कम टू सिमेट्रिक. इफ L1 is perpendicular to L2, is L2 perpendicular to L1? क्या ये वैलिड है? डेफिनेटली ये करेक्ट है. L1 is perpendicular to L2, तो L2 perpendicular to L1 होता है. तो it is symmetric, right? Next, test the transitivity. L1 is perpendicular to L2 and L2 is perpendicular to L3. Is L1 perpendicular to L3? ये हमको चेक करना है. So for example, see here, let me show you. This is L1, line N1. It is perpendicular on L2. And L2 is perpendicular to L3. L2 is perpendicular to L3. So L1 and L3, they become parallel lines. That means L1 is not perpendicular to L3. L1 is not perpendicular to L3. मतलब ये transitive नहीं है. Got it? Okay. चलिए next see. Let's see the next sum. What is there? Let a relation R1 on the set of real numbers. We have to choose from real numbers. AB R1. This is the condition. 1 plus AB greater than 0. 1 plus AB greater than 0. So we have to test this condition for reflexive, symmetric. They are telling it is reflexive, symmetric, but not transitive. So let's check first reflexive. First let us check for reflexive. Okay. So in reflexive we know that it is A, R, A. So now let us apply. So 1 plus A into A. Is it greater than 0? So 1 plus A square is greater than 0. Definitely. देखिए 1 is greater than 0 and A square is always greater than 0. So therefore 1 plus A square is always greater than 0. तो ये reflexive condition है, right? So for if we choose any A from any real number, negative, positive, this is always valid for the reflexive condition. Next come to symmetric. Okay, we will choose A and B from any real number and let's apply now. If पहले हम देखेंगे A R B. A R B means 1 plus AB is greater than 0. Now we will test is B R A valid. So let's see. 1 plus B into A, तो 1 plus A into B, ये भी तो greater than 0 आ रहा है. Yes, that means A R B, that means A R B will also imply that B R A. That means it is valid, so it is symmetric condition. Now let's test for the transitivity. Transitive condition. Let's test for the transitive condition. A, B, C, we will choose from a real set. If A R B, तो इसको कैसे लिखेंगे? 1 plus AB greater than 0 and B R C, इसको कैसे लिखेंगे? 1 plus BC greater than 0. Is A R C means 1 plus AC greater than 0. Let's check. Let's check. A equal to 1, B equal to suppose 2 and C equal to suppose -1. Any number we can take. Okay, so let's check. इसके लिए चेक करते हैं. 1 plus 2 ग्रेटर देन 0, यस करेक्ट। इसके लिए चेक करते हैं 1 minus 2, this is less than 0. Sorry, we have to choose B and C. Let us choose this as plus 3. Plus 3, okay. So this is 1 plus C as 1 minus 2, which is coming less than 0, B and C. So okay, if I choose, suppose, no sorry, this, तो if I choose positive numbers definitely it will happen, लेकिन अगर मैं negative number choose करूं, because it is a real, we have to choose number from the real set. अगर मैं negative numbers को choose करूं, so what will happen? देखिए, this is coming less than 0, right? And this will be what? 1. This will be what? 1. 1 minus 1, which is coming 0, which is not less than 0. Okay, that means the transitive condition is not followed here. Transitive condition is not followed here. We have to choose any number, positive, negative, fractions, anything, because A, B, C should be from the real number. देखिए यहाँ पे बता दे रहा है from the real numbers. Okay, so transitive is valid for the positive numbers, but not for the negative numbers. Clear? Let's check. Determine whether each of the following relations are reflexive, symmetric, or transitive. Okay, so first one, we'll take the first part, and then we are seeing set A is given 1, 2, 3, 4 up to 14, and we have to choose coordinates such that 3x minus y is equal to 0. 3x minus y is equal to 0. Okay, so let's find out the set R. Okay, 3x minus 1 minus y equal to 0. So if I choose x as 1, y as 2, yes, so 1 comma 2 is valid, 1 comma 2 हो सकता है, 2 comma 3 भी हो सकता है. See, if I choose 2, x as 2, y as 3, तो देखिए x as 2, y as 3. So sorry, please hold on. Okay, we have to get 0. So if I choose x as 1 and y as 3, if I choose x as 1 and y as 3, that means I can get 0, right? If I choose x as 2 and y as 6, I can get 0. If I choose x as 3 and y as 9, I will get 0. If I choose x as 4 and y as 8, I will get 0. If I choose x as 5, so I can't choose 5 because then y I have to choose as 15. So these are the things till where we can go. Okay, if I choose x as 5, y should be 15, so which is not possible. तो यहाँ तक मेरा जो है, this is the relation R. Okay, so now on this I have to check whether it is reflexive, symmetric, or transitive. So do we have 1 1 2 2? देखिए ये तो नहीं है, right? So it is not reflexive. It is not reflexive. Now for symmetric, देखिए अगर 1 3 है तो 3 1 होना चाहिए. So it is not symmetric also. Is it transitive? अगर 1 3 है 3 9 है, तो क्या 1 9 है? 1 9 भी नहीं है, सो इट इज नॉट अ ट्रांजिटिव रिलेशन ऑल्सो. क्लियर? नॉट अ ट्रांजिटिव रिलेशन ऑल्सो. चलिए नेक्स्ट. Okay, so we have to choose sets from natural numbers. How? Y equal to x plus 5 and I have to choose x less than 4. तो क्या लेंगे? If I choose x as 1, y will be 6. If I choose x as 2, y will be 7. If I choose x as 3, y will be 8. That is what I can choose because x should be less than 4, है ना? So now let's see, do we have 1 1? No, तो reflexive नहीं होगा, because in the reflexive क्या होना चाहिए? A R A, right? Same coordinate होना चाहिए. We don't have. Is it symmetric? If you have A R B, then you should have B R A. तो क्या है? 1 6, तो क्या 6 1 है? नहीं है, तो it is not symmetric. Now let us see. So in the next part, as you can see here, what was I telling? Yes. So here in the next part, it's not symmetric. Now let's come to the transitive part. In the transitive part, it should be A R B, B R C. So C R A R C ये होना चाहिए. So if you have 1 6, if you have 1 6, तो देखिए इसका 1 6, that means 1 related to 6, तो आपको 6 related to something होना चाहिए. 6 related to something, तो 6 related to something कुछ है नहीं, so it is not transitive also. Next come to third relation. Y is divisible by x. So I can take 1 comma 1 because 1 is divisible by 1. I can take 2 comma 1. Next I can take 3 comma 1. No, I'll take 3 comma 6, sorry. Then I will take 2 comma 4. Y is divisible by x. Sorry, this one is little bit wrong. This part is little bit, इसको थोड़ा मिटा देते हैं. Okay, so we have to always take number y bigger than x so that it is divisible. Okay, so this will be 4 comma 2. I can take 1 minute. First let us complete this. Okay, 1 comma 1, I can take it as 2 comma 1. I can take it as 3 comma 1. This 4 1, 5 1, 6 1. Then I can take 4 is divisible by 2. Then I can take 4 is divisible by 4. Then I can take 6 is divisible by 3. 6 is divisible by 2. 6 is divisible by 3 by 6. I can take 5 is divisible by 1. So 5 is divisible. This I cannot take. Okay. 6 is divisible by 2. Yes. So let's see here. Okay. Any more number? 2 is divisible by 1 and 2 is not divisible by any other. 2 is divisible by 2. Yes, we can take 2 divisible by 2. 3 divisible by 1. So 3 is also divisible by 3. 4 divisible by 1, so 4 is divisible by 4. 5 is divisible by 5. 6 is divisible by 6, we can take that. Next come to 3 is divisible by 3, 3 divisible by, yes, 4. 6 is divisible by 3, 6 is divisible by 1, 6 is divisible by 2, 6 divisible by 3, 6 divisible by 6. Okay, so these are the elements what we can choose. Now let us try the reflexivity. In the reflexivity we have to check A, R, A. Okay, in the reflexivity. So 1, 1 is there, 2, 2 is there, 3, 3 is there, 4, 4 is there, 5, 5 is there, 6, 6 is there. So it is reflexive. 1, 1 is there, yes. 2, 2 is there. 3, 3 is there. 4, 4 is there. 5, 5 is there. And 6, 6 is also there. Correct? Now let's check about the your symmetric relation. In symmetric, A, R, B, so B should be related to A. Okay. Y is divisible by X, so X should be divisible by Y. That means 1, 1. Okay. Now 4 is divisible by 2, so can I tell 2 is divisible by 4? Can I tell 2 is divisible by 4? Never. Never, I cannot tell that. I cannot tell that. If this means X R Y means Y is divisible by X. So if 2 is divisible by 1, so is 1 divisible by 2? Never. So this will never be symmetric, will never be followed. Okay. Now let's come to the transitivity. Let's see the transitivity. Okay. What is transitivity? Y is divisible by X. Z is divisible by Y. Is X divisible by, is Z divisible by X? Is Z divisible by X? Okay, so let's see there. 4 is divisible by 2. So let us take this. 3 is divisible by 1. Okay. 6 is divisible by 3. 6 is divisible by 3. So is 6 divisible by 1? Yes, it is there. See here. For this we don't have, like 2 divisible by 4, but 4 divisible by 4 we cannot take. 4 divisible by, we cannot take anything. Okay, so see, for example, 2 4 means 4 divisible by 2, but after that we don't have anything. 4 divisible by, it should be 8. 8 should be there. Okay, 4 divisible by 8, here it should be like this. It should be like this. 4 8. 8 divisible by 4. 4 divisible by 2, 8 divisible by 4. But 8 divisible by 4 does not belong to the R. Does not belong to the R. That means it is not transitive also. It is not transitive. Clear? Next one. set of all integers, that means I will take all negative positives. X minus y is an integer. So let's check. They are telling x related to y. What are they trying to tell? X minus y is an integer. That we have to check. And x and y we have to choose from the integer set. So let's see. First x, okay, reflexive condition. So x minus x, which is 0, and 0 is an integer. 0 is an integer. That means this condition is valid. Reflexive. That means it is reflexive condition is obeyed here. Okay. Next, x r y is y r x. So let's check. This is telling x minus y is an integer. That means I can tell, let it be k. Now this part means y minus x. So I can write minus of x minus y. That means minus k. So yes, if k is an integer, if k belongs to an integer, so minus k will also belong to the integer. That means symmetric is valid. Symmetric condition is valid. Clear? Next, come to the transitive. X r y, y r z is x r z. Let's check. They are telling x minus y is an integer. Suppose it's k. Z minus y is an integer. Suppose it is m. They are telling is x minus z. X minus z, will it be an integer? So I can write this as x minus y plus y minus z. So this is k plus m. So this is an integer. This is an integer. Integer plus integer is an integer. That means this is also an integer. That means transitive is valid. That means transitive condition is valid. Okay. So the last relation which was this, that means this is reflexive, transitive, symmetric and transitive, all the three. Clear? Now let us see the next one. What is it? Equivalence relation. Equivalence relation. What is equivalence relation? If your relation is reflexive, symmetric and transitive, then we can tell it is an equivalence relation. Equivalence relation. If your relation is symmetric, reflexive, symmetric and transitive, then it is an equivalence relation. Okay. So let's check on this. L1, L, we are testing on the lines and the condition is parallel to. Okay. So first, reflexive. L1 is parallel to L1. Is it possible? Yes. Any line is parallel to itself, so reflexive is okay. In the reflexive, what do we have? We take the same variable on both sides and use my condition. So my condition is parallel to my condition. This is my condition is parallel to. So can a line be parallel to itself? Yes, reflexive is okay. Symmetric. Let us check the symmetric condition. What is symmetric? If x r y is y r x, that means if line L1 is parallel to line L2, is L2 parallel to line L1? Yes, valid. So it is symmetric. Now let's check the transitive condition. What is transitive? If x r y and y r z is x r y, possible. So let's check line L1. If L1 is parallel to L2 and L2 is parallel to L3, is L1 parallel to L3? Yes, is possible. That means transitive is also possible. So see, symmetric reflexive possible, symmetric possible, transitive possible. So it is an equivalence relation. Equivalence relation. So this is a equivalence relation. Clear? If all the three are valid, it is an equivalence relation. Next, let's see. Show that the relation on the set of all integers. So this is, we are showing it on the set of all integers. X minus y. Okay, x minus y is divisible by n. Is an equivalence relation or not? X minus y is an equivalence relation or not? Okay, so let me see. Actually, x and y we have to choose from the integer set. First, reflexive. Which is x r x. So x minus x, which is coming 0. So is 0 divisible by n? Yes, it's correct. So reflexive is correct. Correct. Let's see symmetric. Let's check for symmetric condition. What is symmetric? It is x r y then y r x is possible or not. So let's check. X minus y, suppose it is k, and they are telling k is divisible by n. That means I can tell that k is equal to na, some multiple of a, some multiple of n, because k is divisible by n. Okay, now here we will tell y minus x. So isn't it minus k? Yes. So if k is divisible by n, so minus k will also be divisible by n, because minus k is how much? Minus na, and it is easily divisible by n. Yes, which is coming an integer. So symmetric is also valid. Next, come to the transitive. If x or y, that means x minus y is divisible by n, they are telling. That means let me take x minus y as kn. Okay. And y or z, that means y minus z is divisible by n. That means I can tell let y minus z be mn. Okay, so mn is also divisible by n. Okay, now we have to check is x or z, that means is x minus z divisible by n. That is what we have to check. So let's see. What is x minus z? X minus z, I can write x minus y plus y minus z. So this is x minus y. X minus y is nk, na. It is na plus y minus z is mn. So if I take n common, a plus m, and yes, it is it is divisible by n. Yes, it is divisible by m, isn't it? That means it is transitive also. And if it is reflexive, symmetric and transitive, it is an equivalence relation. Correct? This is also an equivalence relation, right? So let's see now. Let's see another example, friends. This is a set relation 1, 2, 3, 4, 5. A comma b, we have to choose coordinate from here such that mod a minus b is even. We have to show that this is an equivalence relation. So let's see first. Reflexive. So in the reflexive, what will happen? A or a, that means mod of a minus a, and which is 0. So definitely 0 is an equivalence, is even. 0 is counted as an even number. So this is a reflexive relation, valid. Next, come to symmetric. If A or B is B or A, so let's check. A or B means A minus B mod, they are telling, is an even number. That means 2 times of anything, multiple of 2. B minus A, how can I, B or B means this. That means this is minus of A minus B, that means minus 2k, that means 2k. So this is also correct. This is also even number. This is even number, this is even number, that means symmetric is valid. Next come to the transitive relation. If A or B, that means mod A minus B, they are telling is an even number, that means it is 2k. Okay. B or C, that means mod B minus C is also an even number, so 2m. Now A or C, we have to test whether it is even number or not. Okay, A or C. So A or C means mod A minus C. So this I can write it as A minus C plus A minus B plus B minus C. So A minus B is 2k plus 2m. So I can take 2 and k plus m, which is even. That means transitive relation is also satisfied. That means all the three are satisfied. So it is an equivalence relation. It is an equivalence relation. Clear? Next, see friends, what is there? Okay, so we have to, x belongs to the integer set and x is greater than equal to 0, less than 12. That means set A will have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. This is set A. We have to choose numbers from the set A. Mod of A minus B is a multiple of 4, is an equivalence relation. So let's check. Reflexive A R A. Okay. So we have to choose those A minus B which is a multiple, that means R. Mod of A minus B is a multiple. So I can choose from here I have to choose A and B, so that subtraction of them and mod of that is a multiple of 4. That means I can choose 4, 0, 4, 0. Then I can choose 0, 4. Then I can choose 4, 4. Then I can choose 8, 4, 4, 8, and then I can choose 5, 1, 1, 5. I can choose 6, 2, 2, 6. I can choose 7, 1, 1, 7. I can choose 10, 2, 2, 10. I can choose 6, 6. 12, 8, 8, 12, I can choose so in this way we can make many actually we can make many. Now let us check for the reflexive. So here they are telling a minus a mod, which is coming 0, and definitely 0 is a multiple of 4. So that means reflexive is valid. Next come to the symmetric. ARB is BRA. So let's check. ARB means A minus mod of A minus B. They are telling is a multiple of 4. That means 4 into lambda. Well, lambda is any number. Okay, I can tell lambda is any integer. Now BRA, that means I will write B minus A. That means it is minus of A minus B. That means it is mod of A minus B, which is again 4 lambda. That means BRA is also valid. So symmetric is valid. BRA is also coming 4, multiple of 4. Now let's check for the transitive. First ARB, that means they are telling that A minus B is a multiple of 4. So let it be 4 lambda. Then BRC, that means mod of B minus C is a multiple of 4. That means let it be 4k. Is ARC valid? Let me see. ARC means A minus C should be a multiple of 4. So let's check. This I can write like this. This is multiple of 4. This is multiple of 4. Let me take 4 common. So yes, this is also multiple of 4. That means transitive is also coming. That means it is an equivalence relation. It is equivalence relation. Correct? It is equivalence relation. Let's check. So we have to see A, B, R, C, D means A plus D equal to B plus C. So we have to check it for equivalence relation. So let's see. Is reflexive relation valid or not? That means we have to, for reflexive, we have to take the same thing on both sides of R. Okay. So see how they are choosing. A will be chosen with B and B will be chosen with C. So I have to write A will be chosen with B and B will be chosen with A. That means I will write on the left side it will be A plus B. They are telling it will be equal to B plus A. Yes, A plus B is equal to B plus A. That means this is a reflexive relation. Now come to symmetric. A, B, R, C, D is written as A plus D equal to B plus C. We have to check is C plus D, sorry, CD are AB. So let's see. That means I have to take C and B and D and A. So C plus B, is it equal to A plus D? Yes, correct. Yes. That means this is also correct. That means symmetric is okay. Now let's test for the transitive. So for the transitive, A, B, R, C, D means A plus D equal to B plus C. Acha. And now C, D, R, E, F. So this how will I write? I should write C plus F equal to D plus E. Now we have to check. We have to check is AB related to EF relation giving correct? Let's check. See, if I add these two, what will come? A plus D plus C plus F should be B plus C plus D plus E. So what is cutting out? D and D is cutting out. C and C is cutting out. What is left? A plus F is equal to B plus E. That means I can write AB related to EF, right? This is coming correct. That means transitive is correct. So it is equivalence relation. It is an equivalence relation, correct? Next, check. See how they are telling AB, so that we have, this is an equivalent relation. Okay. So reflexive. AB so see how they are taking, if AB equal and related to CD, how they are taking A is going with D and B is going with C. So I will write here AB and BA. So they are equal? Yes, they are equal. A will go with B and B will go with A. So they are telling product on both sides should be equal. Yes, they are equal, so it is reflexive. Now come to the symmetric part. Let's come to the symmetric part. So symmetric part says that AB, R, CD means I have to multiply these two and these two and they are equal. AD is equal to BC. So we have to check is CD related to AB correct? Relation to AB correct? So let's check. I have to multiply these two and these two. Is it correct? CB, is it equal to AD? Yes, AD is equal to BC. So definitely these two are also equal. So symmetric is also valid. Correct. Let's check for the transitive. We have to check AB, R, CD. We will write AD equal to BC. Similarly, CD, R, EF, we should write CF is equal to DE. We have to check, is AB, R, EF? We have to check. So let's see. If I multiply these two, ADCF will be equal to BC DE. Okay, so D and D will cut, C and C will cut, so AF is equal to BE. That means definitely I can write AB R EF, because we are able to choose this and this. That means transitive is also correct. That means it is an equivalence relation. It is equivalence relation. Correct. Let's check another one. AB, R, CD, we have to write like this. AD, B plus C, BC, A plus D. So let's check for the reflexive. AB, R, AB. Okay, so let's check if both are correct. So see how we are doing. AD, that means I will choose AB bracket. Then they will take B plus C, B plus C, that means I will write B plus A. Okay, now this side, how to write BC? That means I will write BA, and in the bracket they are writing A plus D, that means I will write A plus B. Are these two equal? Definitely these two are equal. So reflexive is valid. Next is symmetric. So what is symmetric? AB, R, CD is written as AD, B plus C, and this is BC, A plus D. So they are telling check if this is correct or not. That is CD, R, AB. Is this correct? So how to write this? See, first we have to take what? A and D, that means I will take C and B. So CB, and in the bracket I will write A, D plus A. Okay, and this side I will choose what? BC, that means I will choose DA, and then in the bracket I will write A plus D, that means I will write C plus A. Okay, so let's check if this is correct or not. It is C D B plus A B C, and this side is coming what? C D A plus 1 minute, I think there is something mistake here. C with, I will write A with D, A with D, so I will write C with B, and then in the bracket I will write B plus C, B plus C, so D plus A, correct. And on this side I should write B with C, that means D with A. In the bracket I will write A plus D, That means I will write C plus B. C plus B, sorry. C plus B. Okay. So now it is ADC, and 1 minute, friend. Let me first write it properly, because I think there is some mistake here. Okay. So this, how will I write? Following the rules. See, they are telling first linked with the last. That means C linked with the B. And in the bracket, what should you write? B plus C. B plus C. That means second and third. That means second and third. So which is D plus A. Okay. And here, then this side I should write second and third multiplied. Second and third means DA. And in the bracket I should write first and the last. That means C plus B. Okay. Now see what is happening. Here we can write, they are telling, is this equal to this? So let's check. Let's check. AD. In place of C plus B, from here, what can I write? I can write BC A plus D by AD. Correct? It cuts, which is BC A plus D, and this side is also same thing, BC A plus D. So symmetric is valid. Correct? Symmetric is valid. Now let's check for the transitive. That means A comma B related to C comma D. How will I write? AD B plus C equal to BC A plus D. Okay. Similarly, CD R EF. How will I write? CF D plus E equal to BC. That means DE C plus F. Okay. I have to prove that ABR EF is coming this. ABR ES is coming AF B plus E, and this is coming BE A plus F. So let's check what we can do. So see friends, this part I am doing it here. If I divide these two alternative, this side by this side, so what will happen? See, BC A plus D by CF D plus E, and this side with this side, AD B plus C by DE C plus F. So what we are getting? We are cutting the C, we are cutting the D. Okay, so what we are now getting? B plus A plus F B E, we have to get B E okay. So let's see. So what we can do, friends, I think one more thing what we can do, let us omit this. Okay, we have to get this. So let's see. So what we can do here, that is, see the first part, how can we write? B plus C by BC, A plus D by AD. So this will become 1 by C plus 1 by B equal to 1 by D plus 1 by A. Okay. So let this be equation 1. And now from the second part, from this part, I can write it D plus E by DE equal to C plus F by CF. That means I can write 1 by E plus 1 by D is equal to 1 by F plus 1 by C. Let it be equation 2. So if I add equation 1 and 2, what we are getting? 1 by C plus 1 by B plus 1 by E plus 1 by D is equal to 1 by D plus 1 by A plus 1 by F plus 1 by C. So this cuts, 1 by D cuts. So what is remaining? 1 by B plus 1 by E equal to 1 by A plus 1 by F. That means I can write B plus E by BE is equal to A plus F by AF, or I can write AF into B plus E is equal to BE into A plus F. So isn't this written as, I'm writing it here, isn't this written as ABR and EF? Yes, it is written like this. That means the transitive relation is also valid. That means reflexive, symmetric and transitive all are valid. So it is an equivalence relation. Clear? So please watch this part carefully so that you can understand. Now let's see some special theorems on equivalent relations. If R and S are two equivalence relations, mind it, their intersection will also give you an equivalence relation on A. The intersection of their means elements. Okay, in R whatever you have, in S whatever you have, if this gives you an equivalent relation, this gives you equivalent relation, their intersection what will come will also give an equivalence relation on A. Similarly, If R and S are two equivalence relations, the union of two equivalence relation is not necessarily an equivalence on the set. Intersection will be there, but R union S is not necessarily an equivalence relation. Clear? If R is an equivalence relation on set A, R inverse is also an equivalence relation on A. Please remember these theorems. Sometimes it comes as an MCQ, which will be very important for you. Okay. So friends, with this we have covered up the full relations chapter of the class 12. We have covered up the relations chapter of class 12, and what I would suggest you, please go through each and every part of this carefully and slowly, so that you will be able to understand the full thing. Okay, I have covered up the full relations part of mathematics of class 12. Okay, so I hope you have understood this, and please, if you have understood, please like, share and subscribe. Definitely you do it in my videos so that it spreads a lot, right? Please go through the relations video full. Please go through it full, because if you don't go through it full, you won't be able to understand. I have covered up the full syllabus of class 12. 12 ka pura syllabus I have covered it up. So I would request you, please go through the full video. Go through the full video of this, so you can cover up the full syllabus of the relations which is there in your syllabus for class 12, right? So friends, with this I end my session. So once again I request you, please keep watching Parijat sir classes, keep watching Parijat sir classes, because I am trying to give you all the topics in details, and I'm explaining you some very good numericals in my lectures. So please keep watching my lectures, okay? And I'll be uploading some more chapters of class 12 mathematics. So please keep watching my channel. Till then, it's thank you and goodbye.